So, are you tired of boring old Earth? Want to know what lies beyond the starry night sky? You're not the only one. People have been asking the same question for centuries. Luckily, scientists have got you covered. They've discovered a lot of amazing places light years away from our blue planet. Just one light year is about 6 trillion miles. Mind-blowing, huh? So, hop on. The spaceship of knowledge is lifting off. Your first stop is 2.5 billion light-years away from Earth. It's a quasar, one of the brightest objects in the universe and the first one to be discovered. A quasar isn't a star, but a distant galaxy. This extremely bright object gets its power from a supermassive black hole. A disk of matter swirls around the black hole and creates friction. It's kind of like when you're cold and rub your hands together to stay warm. The friction between the palms creates heat, making you feel nice and cozy. The same happens in the quasar, just the amount of heat is bigger, way bigger. I hope you remember to pack sunscreen lotion. The temperature at the heart of this quasar can reach 18 trillion degrees Fahrenheit. Also, there is light, a lot of it. This celestial object shines 100 times brighter than all the stars in its galaxy put together. Well, it's time to cool down a bit. Minus 457 degrees Fahrenheit, to be precise. This is the temperature of a young planetary nebula called the Boomerang Nebula. It sits 5,000 light-years away from Earth. NASA's Hubble telescope caught images of the formation in 1998. It's composed of gas coming from a star near the end of its life cycle. Inside the nebula, it's windier than in the Windy City. Winds reach speeds up to 310,000 miles per hour. And you gotta thank them for the nebula's chilling temperatures. Researchers were just impressed to find out that the temperature of the Boomerang Nebula is just 1 degree above absolute zero. 0 Kelvin should be the coldest temperature possible. This is the point where all molecular and atomic activity stops. Brr! Makes you want to crank up the thermostat in your spaceship. Next, you're going to a place you might not want to visit. Sorry. So, it's the most massive black hole. This giant is located at the heart of a large galaxy, some 10.4 billion light-years from our planet. Its mass is 66 billion times greater than that of the Sun. Enough to make our galaxy's supermassive black hole feel ashamed. It has a mass of merely 4.5 million times that of the Sun. But you better not get near any of them, as a black hole's diet consists of matter. By calculating how much matter they consume, scientists can determine their rate of expansion. And those black holes have quite an appetite. Astronomers believe there are stupendously large black holes, or slabs, hiding somewhere in the universe. If they're real, their mass is estimated to be greater than 100 billion times that of the Sun. Now, it's time to snack on something lighter. The spaceship enters the Kepler-51 system. It's home to the lightest planets in the known universe, called superpuffs. Sounds fluffy enough, and it is. These planets' mass is either the same or slightly greater than that of Earth. But this doesn't mean they're small. Think of them as giant cotton candies the size of Jupiter. They are newly born planets whose atmosphere is still cooling down. You might want to wait for this process to be over, though, as 500 degrees Fahrenheit is too hot to handle. But for experts, superpuffs are special. These planets are incredibly rare, as they've managed to discover less than 20 so far. Now, are you up for a race? Let's say the ship you're on is traveling at a speed of 25,000 miles per hour. This is the current human speed record. It was set by NASA's astronaut trio from the Apollo 10 mission in 1969. And no, I am not talking about Neil Armstrong and Buzz Aldrin. That was the Apollo 11 mission later that year. Right now, you're going to race against a star 18,000 light-years from Earth. Your biggest advantage is that this is a neutron star. It was formed when another massive star ran out of nuclear fuel and couldn't support itself anymore. Think of a car running on an empty tank. Victory couldn't be any closer, right? Well, not quite. When a massive star feels like its time is up, it shrinks and starts spinning. Figure skaters do the same during a spin. They fold in their arms to increase rotation to the maximum. This neutron star is the champion of the universe. It spins at a speed of 157 million miles per hour. That's roughly 27% of the speed of light. Whoa! Are you running low on energy at this point? Time to charge up from a gamma ray burst. Gamma rays are electromagnetic waves generated by various forms of radiation. These bursts were fairly unknown to science until the late 1960s. Satellites equipped with gamma-ray detectors accidentally recorded huge outbursts of radiation outside of our solar system. What were they? Nothing dark, definitely, as these are the most energetic forms of light. Scientists believe that gamma-ray bursts happen when two neutron stars collide and form a black hole. The other explanation is that they are in the final stage in the life of a supernova. This event happens when a star decides to go out with a bang. Gamma-ray bursts shine brighter than a diamond. They are 1,000,000 trillion times brighter than the sun. Talk about an energy boost. Your mood is lightened up by now. You want to visit a place that has a draw to it. No, it's not a beach resort, but a magnetar. It's a neutron star with a twist. Magnetars have a magnetic field that is 1,000,000,000,000 times stronger than that on our planet. But don't fall for their strong appeal. Let's just say you won't live to tell a tale if you get too close to one. In 2004, a flare that came off the surface of a magnetar managed to compress Earth's magnetic field from a distance of 50,000 light-years. Quite impressive for a star the size of a city. Makes you wish to team up with this oversized magnet to commit the greatest heist ever. A magnetar has the ability to swipe all the credit cards on planet Earth from a distance halfway to the moon. Luckily for humans, NASA has discovered only 31 of these stars so far. You have barely escaped the pull of a magnetar. Suddenly, you start to sense a strange force drawing you away from your home base. It is the Great Attractor, one of the biggest mysteries of the universe. This massive gravitational irregularity has been pulling us closer and closer to it for billions of years. Scientists estimate that the Great Attractor is located at the center of the Laniakea supercluster. The name means immeasurable heaven in Hawaiian. It represents a gigantic collection of planets, stars, and asteroids. Our home galaxy, the Milky Way, is just a speck in this enormous supercluster. According to the Big Bang Theory, not the TV show, the real theory, the universe has been expanding in all directions. But the mysterious Great Attractor is slowing things down. How exactly? Researchers still need to figure this one out. On the bright side, they are good at naming things. The end of the universe would be called the Big Crunch, if there's anyone left to call it that. Your journey, too, ends at the edge of the universe. The most distant galaxy from Earth is the oldest one as well. The galaxies that formed first after the Big Bang have drifted the furthest. So every time advanced telescopes detect a far, far away dot, they give scientists an image of the origins of the universe. You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the sun and wait. Then you'll see Mercury. That's the closest planet to the sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13th, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun. But because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo, there's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet. Different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window. This planet, yeah, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. Ooh. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Baekdu was once 2 stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the 2 stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super-Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system.
One day, NASA will build a spaceship that can take us anywhere in the universe. Probably. And when this happens, we'll be able to find a new, beautiful home. Scientists even know what exactly they're looking for. We want a planet about twice the size of Earth with an average temperature of 77 degrees Fahrenheit, with a pretty dense atmosphere. Bigger planet means more room for water and potential homes. And a dense atmosphere means more protection from nasty space stuff, as well as more lush plants and cool animals. Thanks to the James Webb Space Telescope, we can now study exoplanets better from a distance. Of course, sending astronauts there would be much better, but oh well. Discovering new planets isn't easy though. It's like trying to find a tiny firefly in a pitch-black forest. Scientists had to come up with a clever method to find very distant planets. It's called the transit method. Here's how it works. Scientists capture a series of snapshots of a distant star at different points in time. Then, they scrutinize these images. They try to find any mysterious dark spots passing in front of the star. If they find one, it could very well be a planet. These snapshots hold the keys to uncovering vital information about these distant worlds. Not only do they tell us that there's a planet there, but also reveal its size, radius, and how close it is to its parent star. And most excitingly, they hint at whether it could ever become a new home for us. And now their research is finally bearing fruit. Recently, we've stumbled upon a tiny world nestled in the Cygnus constellation. It's called Kepler-22b. At first glance, it might not seem like a big deal, but this discovery has some pretty huge implications. This planet is located right in the Goldilocks zone. The Goldilocks zone, also known as the habitable zone, is a sweet area around a star where the conditions are just right for a planet to have liquid water on its surface. It's not too hot, so it doesn't evaporate, and it's not too cold, so it doesn't freeze. Hence the name from the famous story of Goldilocks and the Three Bears. So there might be water on Kepler 22b, and where there's water, there's a chance for life. And it's not just about life. Having a planet covered in oceans can be a game changer for climate stability, all because vast water bodies act like nature's thermostats. When the sun beats down on the hot parts, the water soaks up some of that heat and spreads it around like a blanket. The scorching regions cool down and the icy ones warm up and thaw out. Back in the bad old days of our Earth, the moon played a crucial role in helping water puddles spread across our planet. This is what helped our world transform from a fiery nightmare into the vibrant, life-packed orb we call home. Kepler 22b has about the same year length as our Earth. And if we're right about the whole ocean thing, scientists think its average temperature could be around a cozy 12 degrees Fahrenheit. But if this world also sports an Earth-like atmosphere, temperatures might soar up to a toasty 72 degrees. This world isn't too far away from us, only 635 light-years, which is about 3 quadrillion miles. Yeah, that's pretty close in space terms. Its sun is a yellow dwarf star, just like our sun, although there's a subtle difference. It's about 20% dimmer, so you won't see this star in the night sky even if you squint your eyes really hard. This star also happens to be quite chilly. Its temperatures are hovering around a frigid 10,000 degrees Fahrenheit, making it the Arctic of the starry skies. Luckily, Kepler 22b snuggles up to its star a bit more closely than we do to the sun. If it was in our solar system, it would find its place somewhere in between our familiar Earth and Venus. So the brightness and the temperature on this planet would be almost the same as on Earth. There are a couple of catches though. For example, this world might be quite a gymnast. It could be twirling around its star in a totally different way than Earth does. It might be tilted, like Uranus. If that's the case, the temperatures of the planet could be quite weird. You'll experience bone-chilling winters, followed by scorching hot summers. So let's hope this theory isn't true. If Kepler 22b has a normal tilt, its climate would be pretty similar to what we enjoy here on Earth. The next problem is gravity. Kepler 22b is about 2.4 Earth's size, which means the gravity there would be stronger. You'd feel noticeably heavier on this planet. It would be just like doing your everyday activities on Earth, but everything would require more effort due to the stronger gravitational pull. Simple things like climbing stairs or even just breathing would require much more energy. So it's time to build some muscles. People would have to adapt to the new conditions by having denser bones and more robust cardiovascular systems just to move around comfortably. Unfortunately, that means doing sports would be much harder too. But hey, at least people might need to consume more calories to sustain their activities, so even though you'd have to exercise more, you'll also be able to eat more delicious food. Buildings on Kepler 22b would likely be square and robust to withstand the stronger gravity, which would kinda be problematic because taller structures are super challenging and expensive to build. But the most important question is, what kind of planet is that at all? Yeah, it's the big question mark. Scientists aren't even sure that Kepler 22b is Earth-like. It could be a gas giant, or even a water world. A water world is a planet with a vast ocean covering its surface, and it's not just some knee-level deep water. It'll be insanely huge, thousands of miles deep and more, with no visible surface or any plants around for a long time. In that case, we could dream of building underwater cities. We could filter the water for sustenance and perhaps evolve into amphibious beings. Would that be a step backward or a leap forward in our evolution? Some scientists also lean towards the idea that Kepler 22b might be a mini Neptune. This is a legit planetary category, by the way, but that theory is still unproven. But let's say, for our sake, it's a rocky planet. Even then, we're in the dark about its atmosphere. Does it even have one? What if it's like Venus, toxic enough to make your ex look like a bouquet of roses? In that case, we'd have to dig deep into the planet's depths for survival, figure out a heat source, and hope for the best. While there's a lot we don't know, let's keep our fingers crossed and assume the planet is Earth-like. In that case, what would Kepler-22 look like? Well, because of stronger gravity, the planet's landscape might be full of rugged mountains, deep valleys, and powerful rivers. If there's life on this planet, it's probably quite small? Unusual plant and animal life should have adapted to the higher gravity. Trees might be shorter and sturdier. They'd struggle to break free from the soil. Animals might be pretty small too. They would also have strong, muscular legs for support. Perhaps these creatures would have numerous legs, making movement possible. They'd need to be small in stature, but gargantuan in strength. Muscular giant spiders sound not so bad, right? As for our beloved pets, they'd have to become little muscle-bound spheres just to survive. Also, the landscapes would feel very spacious because of the planet's sizes. A 3-day flight in a plane sounds like quite the adventure. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer the planet. That would be awkward if it turns out to be a gas planet or something like that.
In 2021, astronomers announced that they had found between 70 and 170 free-floating planets. Such planets are also called rogue because they don't orbit around any star. And the majority of these huge unattached planets, each approximately as large as Jupiter, dwells in one particular region of the Milky Way galaxy. It's known as the Upper Scorpius OB Stellar Association. Wow, doesn't it sound like the name of some homeowners association? Anyway, this conclusion was made by a team of astronomers that used telescope observations from all over the world and in space. They also looked through 80,000 wide-field images taken over a couple of decades. Scientists have estimated there might be billions or even trillions of rogue planets wandering around our galaxy. If their estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Ooh. This region of the sky is around 420 light-years away from Earth. A lot of amateur astronomers are familiar with it since lots of cool stuff is located there. The most famous targets for astrophotographers include dark nebula, like Barnard 68, Coal Sack, or Pipe Nebula, as well as the colorful region around Rho Ophiuchi. But let's get back to mysterious rogue planets. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. Recently, astronomers have announced one more finding, the tiniest known rogue planet. The mass of this space traveler is somewhere between the masses of Earth and Mars. The term itself, a rogue planet, suggests that such celestial bodies might desert their stars on purpose. They wander off on their own, carving a new path through the Milky Way. But the reality is much more tragic. Rogue planets are usually kicked out of their star systems, doomed to a solitary existence of circling the center of the galaxy on their own. How sad. You see, things get messy when planetary systems, including ours, form. While planets appear from the cosmic dust surrounding a newborn star, they jostle one another around. This gravitational game of pool can easily shove some planets toward the edges of a star system, or eject one or two of them altogether. Then there are also nearby stars that can shove planets around too. Most stars are not born on their own. Clusters of dozens to thousands of stars often appear in space. No wonder that in such a crowded environment, a star with its own set of planets might whisk away a planet or two from another star. After stealing a planet, it can keep it for itself or cast it out into space. At the same time, some free-floating planets might form in a different way, with no parent star to help them. They appear from collapsed clouds of gas and dust, just like stars do. But sadly, they don't manage to put on enough weight to start nuclear reactions, the ones that make stars emit light. These objects are also known as failed stars. Hey, who said they failed? And they resemble planets. Rogue planets are very hard to detect. When astronomers want to find an exoplanet, they look for something blocking the light of its parent star. That's usually the planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because, in this case, there's no parent star. The only way to locate them is to rely on gravity. Now, imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the star's light. This, in turn, makes the star appear brighter than usual. As for the duration of this brightening, it depends on the nature of this moving object. If the brightening lasts a few days, it's a star. If the duration is about a day or so, it's a Jupiter mass object. And if it's just a couple of hours, this object is something that equals the mass of our planet. But the trickiest part is to figure out whether this object is indeed a rogue planet. It's true that stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there still might be a parent star, invisible because of the glare of the luminous star. And astronomers have to wait up to a decade for the luminous star to move a bit to check for a potential parent star. If there's still no parent star in sight, then it's proven. The planet is traveling solo. One thing is clear. Without parent stars to warm them, rogue planets are frozen worlds. Even if ice doesn't go all the way down to their cores, it certainly covers such planets with hard, icy shells. On the bright side, maybe free-floating planets aren't as lonely as we think. They might have moons of their own. They probably take them along when they get pushed out of their cosmic homes. Even more exciting, these exomoons might have liquid water. At least that's what a 2021 study published in the International Journal for Astrobiology claims. Actually, I don't get that magazine, but it sounds fancy. But could a free-roaming world find a new home near a different star? Some experts think it's unlikely. The universe is an incredibly spacious place, and even a large star is hardly able to slow down enough to lasso a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or slowing down. But what if it was a rogue planet? Would it stay with us? Astronomers say it's unlikely. If it happened, they would be thrilled, such a research opportunity. But the rest of us would likely be terrified by the implications of having such a neighbor. At the same time, maybe it wouldn't be such a big problem, considering how big and very empty our solar system is. But even without a rogue planet invading our solar system, the orbits of our planets are going to change one day. In 5 billion years or so, the sun will start to dim. It'll begin to lose its mass until its gravity is too weak to hold on to the outermost planets of the solar system. Neptune, Uranus, and probably Pluto might turn into rogue planets. They will slowly drift away, unbothered by the cold and mostly unchanged due to their already frozen environments. And yeah, I know the scientists demoted Pluto as a planet years ago, but it's still a planet to me, so sue me. And what about Earth? Oh, our planet will have a different fate, much more tragic. As stars lose mass nearing the end of their lives, they eject gas and dust in all directions. And since our planet is in the way, it'll most likely get enveloped in this scorching stream and vaporize. But calm down, it won't happen for a few more billion years. And who knows where humanity will be at that time. As for now, astronomers hunt rogue planets with enthusiasm. For example, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey to discover more free-floating exoplanets using its powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept, cleverly called Cleopatra. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. To maximize this effect, Cleopatra might hitch a ride on a Mars-bound mission. It's supposed to place it in orbit around the Sun. That's a sufficient distance from Earth, which can help the mission effectively measure the parallax signal and fill in the missing information for astronomers. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to higher resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.
Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios. More of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. That's where the idea of planetary intelligence comes in. Just like individuals and groups can be intelligent, so can an entire planet. Researchers believe we should measure the planet's intelligence by its ability to keep itself going forever. And just like how humans need to work together to survive, a planet's collective intelligence is measured by the capacity of all the life on it to work together towards this same goal. It's like the planet is a complex system that knows how to take care of itself. like forests. They can share nutrients through their secret underground networks of fungi. This helps all the trees stay healthy. We can obviously learn a lot from forests. If we jump into the fantasy universe while looking for intelligent, conscious planets, we'd definitely choose Mogo from Green Lantern. It's a specific planetary entity that can do things like changing its weather and altering gravity, plant growth, or some other surface conditions. Or how about the stunning Pandora from Avatar? Do you remember the fascinating scenes of flora and fauna there? With organs that might remind you of tentacles. They enable creatures to interlink with each other on a neural level. It's like the entire planet is like one giant brain, with many smaller trees, creatures, and its other pieces as its cells. We're far from that. Could generally become sentient, like Pandora or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers used different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on the super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
This planet is as light as that piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b, but let's call it the Cotton Candy Planet. It's located around 1,200 light-years away from us. Sure thing we'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin, 50% more massive. It has an extremely low density combined with other factors, such as high temperatures and the infrared brightness of its host star, that make it look special. May I have a close-up here, please? Thank you. See how fluffy it is? Right now, you understand that it would be impossible to stand on its surface. Anyways, it's not often that you meet something like WASP 193b at a planetary party. Such planets might be fluffy because they're getting cooked by their parent stars, puffing up like a marshmallow that's seen too much campfire action. But the thing is, if you're that close to your star and mostly made of a hydrogen-helium cocktail, you're not gonna keep your puffiness for long. It's like trying to hold on to a balloon during a hurricane. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 10007b, and it looks squishy too. This one kicks back 200 light-years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet is a copycat of Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure, but WASP 10007b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI-cam. They spotted clouds made of the stuff that builds beaches, silicate, or as you might know it, sand. Imagine sandcastles in the sky. Those sound clouds are way up there in the penthouse suite of WASP 10007b's atmosphere, where the thermostat reads a breezy 932 degrees Fahrenheit. Normally, you'd need 1,832 degrees Fahrenheit to cook up this kind of cloud, so scientists are scratching their heads. How did those grainy puffs get all the way up there? Turns out, WASP 10007b might be running its own sandy water cycle, but with scorching silicates instead of H2O. Silicate particles get whooshed up from the sizzling lower levels by some sort of cosmic elevator, and then they cool off, party together as clouds, and sprinkle down a silicate drizzle. Nobody's packing sunscreen for this kind of sandstorm, though. Now look at this Kepler planet family located in the Kepler 51 star system. This cosmic three-pack hangs around 2,400 light-years away, looking huge but having the same density as your favorite snack. And it's cotton candy yet again. Scientists have been digging into what these space treats are made of. They now believe these puffball planets are big hydrogen-helium gas balloons with a generous smearing of methane haze. It also turns out these planets might be going through a cosmic downsize. Now, let's talk about a planet called Mascara 5b. Nope, it doesn't look like one of those cosmetic tubes from your mom's drawer. Scientists say it's one of the hottest planets ever discovered. They call it an ultra-hot Jupiter, showing off its impressive size, almost twice as big as our very own Jupiter. The dayside temperature is around a scorching 4,892 degrees Fahrenheit, while the night side hits 4,172 degrees Fahrenheit. No chance for any sort of life to survive out there. Actually, it's the second hottest night-side temperature ever recorded. To put it in perspective, the temperature of molten lava sits between 1,292 degrees Fahrenheit and 2,282 degrees Fahrenheit. So, the planet is a whole lot hotter than this scorching liquid rock. Its temperatures even surpass the melting point of most metals, which is around 3,632 degrees Fahrenheit. Scientists mention that the insane heat on this planet is comparable to the exhaust of a rocket engine. Back in 2005, one famous star called... Wait, is that a name or a phone number? Whatever. So, turns out this star has a hot sister, and they have very similar names. this hot sister has B at the end. Well, this place looks like something from a sci-fi movie as it rocks a mesmerizing blue marble vibe, according to NASA. Such an appearance results from an atmosphere packed with hazy clouds laced with glass. The rain on this planet is glass-filled precipitation that likes to fall sideways, thanks to fierce winds blowing at a speed of 5,400 miles per hour. And yeah, it's the hot sister for a reason. Scientists have measured the daytime temperatures in this nightmarish world. It's around 1,700 degrees Fahrenheit. So when it rains on this planet, it's more like molten glass pouring down instead of your typical waterworks. You may not know it, but space is swarming with wasps. I'm talking about planets called WASP. Meet WASP 76b. This sizzling hot Jupiter-like planet is so out of this world, it rains iron at night there. The daytime side is no less of a fiery nightmare. The temperature there is about 4,300 degrees Fahrenheit. WASP 76b may be slightly smaller than Jupiter, but don't underestimate its grandeur. This fireball is located 640 light-years away from Earth. And its terrifying climate is the result of one seriously extreme orbit. You see, these gas giants are fittingly known as hot Jupiters. They like to keep it hot, so they orbit way too close to their scorching host stars. In this case, WASP 76b is nearly 10 times closer to its star than Mercury is to our Sun. That's way too close for comfort, leaving this rebellious planet tidally locked to the star. So, while one side basks in eternal light, the other is trapped in perpetual darkness. 55 Cancri e is a total gem. It's the raddest super-Earth ever spotted. Scientists initially believed it was packed with so much carbon that its insides were blinged out with diamonds, thanks to insane pressure and sizzling temperatures of 4,892 degrees Fahrenheit. But researchers put a dent in the diamond hype, showing there was actually less carbon than we had originally thought. Well, diamonds aren't actually that rare and expensive after all. They're just well marketed. The last destination for today is GJ 1214b, located 40 light-years away from Earth. This planet is like a supersized Earth, almost 3 times bigger in diameter and a whopping 7 times heavier. It orbits around its red dwarf star faster than you can finish a pizza, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on GJ 1214b create some super cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo on being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. How do people usually describe planets? Massive, freezing, boiling hot, seismically active. Let's admit it, shiny is not normally on the list. Unless we're talking about a world called LTT 9779b, which might be the shiniest planet we've ever seen. This exoplanet, which is basically any planet outside our solar system, is ultra hot and acts like a giant space mirror because it's covered with a thick layer of reflective metallic clouds. This unusual world is located about 264 light-years away from our planet. And the most amazing thing about it is that it reflects approximately 80% of all the light its parent star sends its way. For comparison, Earth reflects a mere 30% of the light it gets from the Sun. The bizarre exoplanet is even more reflective than the shiniest planet in the solar system, Venus, which reflects around 75% of sunlight due to its thick clouds. LTT 9779b is 5 times as large as Earth, which makes it the largest space mirror ever discovered. By the way, this world was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. But the highly reflective nature of the planet was uncovered later thanks to a follow-up investigation conducted by the European Space Agency Exoplanet Hunting Spacecraft, CHEOPS, which stands for Characterizing Exoplanet Satellite. Now, imagine a planet the size of our ice giant Neptune. It's a burning world floating close to its star. If you stepped on its surface and looked up, you'd see heavy clouds of metals floating over your head, raining down titanium droplets. The planet's size, coupled with its insane temperatures, allow astronomers to classify the planet as an ultra-hot Neptune. Now, a planet's high reflectivity is a quality known as albedo. And in the case of our shiny world, its albedo mystifies scientists. All because most planets that are not ice worlds, or planets with thick layers of reflective clouds like Venus, normally have low albedos. Their atmosphere or surfaces simply absorb the light coming from their stars, preventing it from getting reflected back into space. And initially, researchers were sure that LT 9779b would have a low albedo. After that, by no means was it an ice world. Not with the surface temperatures reaching 3,650 degrees Fahrenheit on the side of the planet permanently facing its parent star. It was supposed to be too hot for water clouds to form. Even clouds of metal or glass wouldn't be able to form in such a scorching climate. Astronomers expected a planet like that to have its atmosphere destroyed by its star, which would leave behind a lifeless, rocky world. That's why discovering metallic clouds was so unexpected. Of course, researchers were eager to find out how such clouds could have formed. It had remained a mystery until they decided to think about the cloud formation in the same way as condensation that appears in the bathroom after you take a hot shower. There are 2 ways to steam up your bathroom. You can cool the air until the water vapor condenses, or you can keep hot water running until clouds form. It will happen when the air in the bathroom becomes so saturated with vapor that it won't be able to hold it anymore. So, researchers came to the conclusion that most likely the atmosphere of the shiny planet became oversaturated with silicate at one point. And then, metal started vaporizing due to boiling hot temperatures on the permanent day side of the planet. But if you think that the reflective nature of LT 9779b is its only unusual feature, you might want to hear this. The exoplanet is an example of an extremely rare planetary type, and ultra-hot Neptune. Astronomers have been searching for such planets for decades, but those preferred to remain a mystery. The fact that the planet survived so close to its star might be linked to its high reflectivity. Some experts believe that the metal clouds covering the planet probably reflect light and prevent the planet from overheating and evaporating. Plus, such a highly metallic atmosphere is much heavier and harder to blow away than any other. Now, about 850 light-years away from Earth, a planet called WASP 121b orbits its star. This planet is a hot Jupiter, which means it's a gas giant moving very close to its star. And because of such a short distance, the planet is also insanely hot. The average day temperature there is around 5,000 degrees Fahrenheit. Interestingly, just like our previous shiny world, this planet also has metallic clouds floating over its surface. But that's not the only oddity. WASP 121b has a bizarre oblong shape. Can it be because the planet is tidally locked to its star? It means that one of its sides always faces the star, while the other is always turned to the darkness of the cosmos. In other words, it's always daytime on one side of the planet and nighttime on the other, which causes crazy temperature differences. Researchers think it might be the reason for the metallic clouds. The water cycle on WASP 121b is also pretty bizarre, to say the least. On the illuminated side, the atoms that make up the planet's water get ripped apart by the insane temperatures. After that, they get blown by winds moving at 11,000 miles per hour to the other side of the planet. There, much lower temperatures allow the atom to recombine into water molecules. At the same time, the nighttime side is cold enough for metal clouds consisting of iron and corundum to form. When these clouds migrate to the daytime side of the planet, they vaporize and rain down metal on the planet's surface. But if these clouds don't seem impressive enough, I've got more. Astronomers predict that the planet will rip itself apart in the next several million years because of its incredibly fast winds and wild temperatures. Plus, the gravitational pull of the planet's parent star also plays its role in this dark prediction. Since WASP 121b is so close to the star's gravity pulls the planet into a weird oblong shape and makes gases like iron and magnesium leak from the planet's atmosphere. This pull is so strong that the planet is always on the verge of a tidal disruption. If it ever happens, the planet will come apart for good, metallic clouds and all. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists got some proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. Another planet you probably shouldn't set foot on is WASP 76b. There, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit larger than Jupiter in terms of size and is located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between the planet and its parent star is 10 times shorter than the distance between Mercury and the Sun.
Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds, such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, They're squeezed so hard that the cloud starts to flatten into a disc shape. Kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets. And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical, or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep-angled gravity. Walking on those edges would feel just like climbing a mountain, or walking on a super steep slope. All because gravity wants you right in the middle of the face, and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities, so keep your imagination soaring and continue to marvel at the marvels of our amazing planet, however it may be shaped.
A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come.
25 light-years away from Earth, in the constellation Lyra, there's a young star, Vega. The brightest and one of the most famous, this star is twice the mass of our Sun. Vega is so brilliant, you can see it even at twilight when all the other stars disappear from the sky. Despite all the star's fame, astronomers have never seen a single planet orbiting Vega, until recently. Researchers have been observing the star for a decade or so when they spotted a curious signal. It might be Vega's first world we'll know about. If it did exist, it'd be a marvelous place. The planet would likely orbit so close to its host star that one day on it would last around 2.5 Earth days. The world would be the size of Neptune, and this ice giant is 4 times wider than Earth. Or it might even be as large as Jupiter. But the most impressive thing about this potential planet would be its temperature. The place could turn out to be the second hottest world known to scientists. On its surface, it'd be as hot as 5,400 degrees Fahrenheit. For comparison, the temperature on the surface of the hottest planet in the solar system, Venus, doesn't rise above 900 degrees Fahrenheit. The only place hotter than Vega's potential companion would be Kelt 9b. The temperatures on this exoplanet don't drop below 7,800 degrees Fahrenheit. Anyway, the candidate world would be closer to Vega than Mercury in our solar system is to the Sun. It could result in the giant planet puffing up like a balloon, and then even metals would melt in its scorching hot atmosphere. Unfortunately, the existence of the sizzling planet has yet to be confirmed. Astronomers think that the easiest way to prove it is by trying to spot the light emitted by the unusual planet. And since we're talking about planets, are there any worlds out there that resemble Earth? Astronomers have discovered and confirmed more than 4,000 exoplanets, but it's no secret that thousands of other candidates are still waiting for their turn to be detected. Of course, not all of these planets are like our Earth, but some are. For example, Gliese 667cc. This world is only 22 light-years away from Earth. Scientists aren't sure if the planet is rocky, but they know the place is more than 4 times as massive as our planet. The star of Gliese 667cc is a red dwarf. That's why it's much cooler than our Sun. So, the exoplanet is likely to be in its star's habitable zone. But this idea hasn't been confirmed yet. The Earth-like planet might be moving too close to the star. Then it can be regularly baked by its flames. Kepler 22b is much farther away than the previous world. If you wanted to reach that planet, you'd have to travel 600 light-years. This world, which is more than twice as large as the Earth, lies in the habitable zone of its host star. But it's unclear whether it's liquid, gaseous, or rocky. Kepler 69c is almost 70% bigger than our planet. It's also very, very far away, 2,700 light-years. It'd take you 54 million years to travel the distance that great in a modern spacecraft. Researchers aren't sure what Kepler 69c consists of, but they think it's likely to lie in the habitable zone. The planet's position in its solar system is like that of Venus and ours. But since the host star is only 80% as bright as the Sun, the planet shouldn't be affected by its heat that greatly. Kepler 452b is the most Earth-like planet astronomers have discovered so far. It resides 1,400 light-years away from our planet. Its host star is very similar to our Sun, and the planet, lying in its habitable zone, is 1.5 times the size of Earth. Scientists also think that Kepler 425b is likely to be a rocky world. Are any of these or other planets besides Earth suitable for life? There are 24 potentially super-habitable planets, and one of them met not one, but 2 criteria astronomers have for such worlds. KOI 5715.01 is 5.5 billion years old and around twice the size of Earth. It orbits an orange dwarf a bit less than 3,000 light-years away from our planet. Its surface temperature might be 4 degrees Fahrenheit cooler than that of Earth. But since the planet's atmosphere might have more heat-trapping gases, the place is likely to be super habitable. Another potential super habitable planet is KOI 5554.01. This world is a bit older than our planet, 6.5 billion years against our 4.5 billion. The exoplanet's size is likely to be the same as Earth's. The planet orbits its host star, a yellow dwarf, and the average temperature on its surface is 80 degrees Fahrenheit. What planets are visible from Earth? Mercury is the nearest to the Sun in our solar system, but since this planet is so close to the star, you can only see it just after sunrise, in the early morning, and at dusk. From up close, the place looks a bit like the good old moon. The planet doesn't have an atmosphere, and the temperatures on its surface are extreme, 800 degrees Fahrenheit during the day and minus 290 degrees Fahrenheit at night. Venus is the second brightest celestial object out there after the moon. It's one of our planet's closest neighbors. Also, it's the most similar to Earth in terms of gravity, size, mass, and average density. Unfortunately, you won't be able to see Venus's surface from Earth. A thick layer of clouds is securely hiding the planet. Jupiter can be either the third or fourth brightest object in the sky. It depends on Mars, which occasionally shines brighter than the gas giant. You can see Jupiter especially well in the summer. The gas giant's most famous feature is the Great Red Spot. That's an enormous storm that has been raging on the planet's surface for centuries. Even though the largest planet in the solar system looks like a solid sphere, you wouldn't be able to land on its surface. Jupiter is mainly made up of gases, mostly helium and hydrogen. Saturn is the second largest planet in the solar system. It's the last one of the 5 planets you can see from Earth with the unaided eye. Saturn is incredibly far from Earth, but its unique rings help you instantly recognize this colossal planet. It's a pity that Saturn's trademark feature is only visible in a telescope. By the way, more than 700 Earths would fit into Saturn. At the same time, the gas giant's density is a mere 1/8 of Earth's. This is why Saturn's mass is just 95 times greater than that of our planet. What planets in the solar system are closer to each other than the rest? Astronomers believe that Mercury is the closest to any other planet in the solar system. And that's quite shocking because, how about Venus? It orbits the Sun between Mercury and Earth. Isn't it supposed to be closer to our planet? Venus is indeed rather close to Earth, but only for a very short period in its orbit. The rest of the time, Venus is much farther away. But Mercury's orbit doesn't let the planet move too far away from the Sun, and it's closer to Earth more than 50% of the time. The same principle works with other planets too. Even gas giant Neptune is farther from Uranus than from Mercury. Most of the time, the 2 larger planets are on the opposite sides of the solar system. Their orbits sometimes do bring them very close to each other, but it happens very rarely. And how about planets outside the solar system? Astronomers have recently discovered 2 worlds traveling around the same star. Their orbits are often so close to each other that each planet looks like a huge full moon from the surface of the other. It occurs every 97 Earth days. These planets are about 1,200 light-years away from Earth. Their composition and size are different, but the distance between them is a mere 1.2 million miles. That's 5 times the distance between Earth and the Moon, and it's closer than any other planets astronomers know about. One of the newly found worlds is more than 4 times as massive as our Earth. It's likely to be rocky. The other is a gaseous planet the size of Neptune and almost 8 times as massive as our planet. Scientists haven't figured out yet how such dramatically different space bodies ended up in such similar orbits.
2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable, for us? Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is. And that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxies by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the 4th planet in its system, and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect, but when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency. Toys Were Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys Were Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day, or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of 2 exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these 2 Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri b is the closest Earth-mass exoplanet at 4.2 light-years away. So, these 2 new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay. since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with two instruments, espresso and Carmini's. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, "Nature seems bent on showing us that Earth-like planets are very common. With these two, we now know 7 in planetary systems quite near to the Sun. Who knew our neighbors could be so friendly?" In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP 890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The two planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling Bob is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the second most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys R Us, Wolfie and her mama will all be out there waiting for us.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's Infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1. And recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
Jupiter has 79 known moons, and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is negative 250 degrees Fahrenheit at the equator and around negative 360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42.5 hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the third biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts. Water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons. The weird thing about Fomalhaut b isn't its name, but the fact that it doesn't exist. It was first photographed back in 2008 and was a sensation. Scientists believe it to be a massive exoplanet, but it turned out to have low mass, and it's falling to pieces of dust at the moment. It acts like a massive dust cloud. Gliese 1214b is quite extraordinary with its steamy environment. Wait, but steam is the result of water evaporation, isn't it? In fact, this hot planet is full of water-like substances. It's definitely hotter than our planet, with its 250 to 540 degrees Fahrenheit. It can also be an ocean planet. Still, very little is known about it since it was first discovered only back in 2009. If you ever wondered what it's like to walk on ice and hot coals at the same time, meet Gliese 436b. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven. And yet, it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. But Gliese seems a nice place with quite mild climate compared to an oven-like Corot 7b. Its day-to-day temperature is over 4,000 degrees Fahrenheit. Combined with the rocky surface, it presents a kind of underworld landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Corot 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. Corot XO 3b is neither as hot as the previous one, nor as cold as many other planets. It's a gas giant similar in size to Jupiter, yet 20 times denser. It makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. TRES 2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here, it's pitch dark and scorching hot. TRES 2b is a gas giant, roughly 1.5 times more massive than Jupiter. and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. It may mistakenly seem that Saturn does have an Earthen-friendly environment. Some layers of this giant gas sphere actually have quite nice temperature conditions. If you dive into Saturn, you'll get to a layer with liquid molecules with 32 degrees Fahrenheit, which seems like Earth. Anyway, it's only one minor layer, and the rest of the planet is freezing cold. So you'll never be able to land on Saturn and be the same human being like you are on Earth. But you can become a sort of snowball there, or an ice crystal. As for Jupiter, you might have already guessed that there's no solid land. This planet is made of hydrogen and helium, so it's another gas sphere you can't walk on. It's a bit different from Saturn though. You wouldn't dive in Jupiter, you'd rather float on it. This planet is like a giant cloud, and if you ever landed on it, it would be like walking through a super thick fog. The temperatures fluctuate a lot here. It's freezing on the surface. Unlike Saturn, the deeper you dive, the more scorching this gas sphere gets. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot where anything that could burn will. It's also responsible for a very short orbit of the planet around its star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. WASP 76b is another weirdly dangerous planet where it rains. No, not wasps. It's so hot out there, over 4,300 degrees Fahrenheit, that it vaporizes iron. So, it rains iron. It's another gas giant, just like Jupiter. Its extreme proximity to the Sun divides the planet in two. One half has a never-ending day, while the other has eternal night. Meet WASP 12b, one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planet consisting mostly of gas, result in the star slowly devouring its protege. WASP 12b has already taken the form of an egg, stretched towards its merciless sun and unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. No list of the weirdest planets could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury, despite being somewhat farther from the Sun. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water, but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through those clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. One more freezing cold planet is the one I dare not pronounce. Although the host star is not too far away, it's a small and rather cool red dwarf whose light and heat barely even reach the planet. The temperatures out there fall as low as -370 degrees Fahrenheit, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice. Still, if it has a rocky core, it might generate some heat, so there is a chance that deep below the frozen surface, we could build a nice thermal spa hotel for space travelers. The next planet that sounds like a tongue twister is the only exoplanet in the orbit of its star, and at first glance, it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst thing is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. For comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Here's another name we'll just leave on the screen, thank you. This magnetic rogue planet, let's call it SIMP, has probably the best auroras in the universe, putting our northern lights to shame. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees Fahrenheit, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when these cool down, they fall on the surface in the infernal rain of molten iron. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather, the first, because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star with one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. The system, whose name I wouldn't even try to pronounce, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular one. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions, while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely.
TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, oh, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second, As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that somewhere. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Quasar 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Quasar 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core.
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. it would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620 26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its 2 host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star. not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called ERAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both ERAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The 2 detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper Belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be 2 unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we